Hello, everyone. Welcome to the Math Magician's Den. We are going to discuss limits today that involve factoring and canceling. Now, if you were to take a look at all of these problems on this page, the one thing that you're going to determine is that I have rational functions and they're always polynomials over polynomials. So one thing I can do is I can plug in the numbers to see if they work. So if I plug 1 into this first limit, I'm going to get 1 squared plus 3 times 1 minus 4. Well, that's going to give me 0 on the top. And the bottom, I'm going to get 1 minus 1. Well, that's going to give me 0 as well. So 0 over 0 is an indeterminate form. I can't just plug in the number here to find the limit. I'm going to have to find another way to do this. So what do? Well, with rational functions, if you studied them in the past, one thing you can do is you can factor the top, factor the bottom, and see if anything cancels out. Well, that's exactly what we're going to do here. We're going to take this limit as x approaches 1, and we're going to factor the top because the bottom is already done for us. How does the top factor? Well, the top factors into x and x. That gives me x squared. And of course, I've got to figure out two numbers that multiply to give me negative 4, but add up to 3. And that would be plus 4 and minus 1. That's our factorization. Now take a look at what I've got here. I have two factors that are going to cancel. The x minus 1s are going to cancel. Now, what's crazy about this is that x minus 1 over x minus 1, if you plug in 1, that's the 0 over 0. So one thing you can look for on these problems is if x is approaching 1 and you've got a 0 over 0 situation, there's probably its corresponding factor in the top and the bottom, x minus 1. If x is approaching 2, there's probably an x minus 2 on the top and the bottom, and so forth. But what happens here is I'm going to cancel those out, and my remaining limit is just going to be the limit as x approaches 1 of x plus 4. And if I plug in 1, my limit is going to be 5. So it's the same kind of thing. We're going to move to the problem that's just below it. And I'm just going to tell you right now, if I were to plug 2 into the top, I'm going to get 0. If I plug 2 into the bottom, I'm going to get 0. This is, again, a 0 over 0 situation. It's an indeterminate form. So what I'm going to do, I'm going to do the same thing I did before. I'm going to take the limit as x approaches 2, and I'm going to factor. Now, like I said before, if there's an x approaches 2 and you get 0 over 0, there's going to be its corresponding factor, x minus 2 on the bottom, and it's going to be x minus 2 on the top. Now, the top is a difference of squares, so it's going to factor into x minus 2 and x plus 2. And notice again, I've got some factors that are going to cancel out here. My x minus 2s are gone. And ladies and gentlemen, again, that x minus 2 over x minus 2, you are canceling out the 0 over 0. So how do I finish out my limit here? Well, I can now just plug in the 2. 2 plus 2. My limit here is 4. So these were some simple limits that we could discuss. Now, there's a few other ones on this page where I've kind of challenged you with the factorizations. This problem in the upper right, what's going to go on with this particular question, we've actually got a difference of cubes. If you plug negative 2 into the top, you're going to get 0. If you plug negative 2 into the bottom, you're going to get negative 8 plus 8, which is 0. Now, what does that mean for us? It means for us that if x is approaching negative 2, I should have an x plus 2 on the top because that would give me a 0. And I also should have an x plus 2 on the bottom. Now, how do you factor a sum or a difference of cubes? I'm going to write the formula at the bottom of the screen real quick here. If it is a cubed plus b cubed, the formula works like this. It would factor into a plus b. Now watch the a's. Go one power less. The first term would have a squared. The second term would have a to the first. The last term wouldn't have an a. The powers of b go backwards. So here we would start out with b squared because I already have a b right here. This one would have b to the first. This term would have b to the 0. Yes, that pattern works every time. If this is plus, the rest of the signs alternate. They go minus, plus. That, ladies and gentlemen, is the factorization for the sum of cubes. For a difference of cubes, all you have to do is put a minus sign here. This would be minus, and the thing about it, the rest of the way, they're all pluses. And this pattern actually does work for higher powers as well. If you were doing a to the fifth plus b to the fifth, this would factor into a plus b first. Now watch the a's. A to the fourth, a to the third, a to the second, a to the first. Last term doesn't have an a. The b's go backwards. B to the fourth, b to the third, b to the second, b to the first, and no b. If this is a plus, the rest of the signs will alternate. If this is a minus, well, this would be a minus, and these would all be pluses. Maybe you want to pause the video and write those down or take a picture of that, because I'm going to erase those so I got more room to do these questions, but I'm going to use this formula up here at the top before I move on. How would I do this factorization? Well, I would have x squared, x, no x, 2 squared, 2, no 2. And this is plus, so this would go minus, plus. There's my factorization. Let's keep going with this limit up here. Can you see that the x plus 2's are going to cancel? Now, ladies and gentlemen, that is essentially the 0 over 0 in the question. So now what I can do is I can take the limit as x approaches negative 2 of 1 over x squared minus 2x plus 4. And I'm going to plug in negative 2. That would give me 4 plus 4 plus 4. My answer here would be 1/12. So when you have higher powers, you should be able to factor those as well. But notice how we're factoring the top and the bottom. And really, we got a hint. Look at the next problem, and I'm going to do some erasing while you look at that. We have a difference of fifth powers on the top. And I think you can already tell that if I plug in 1, I'm going to get 0 over 0 for this question as well. I'd get 1 to the fifth minus 1 over 1 minus 1. That's going to give me 0 over 0. Now, how does this thing factor? Well, remember, if x is approaching 1 and you get 0 over 0, you have to have x minus 1 on the bottom, and you got to have x minus 1 on the top. Now, let's use that pattern we just learned. I already have an x, so this would start out x to the fourth, x to the third, x squared, x, and the last term wouldn't have an x. Going backwards, it'd be 1 to the fourth, 1 to the third, 1 to the second, 1 to the first, and 1 to the 0, which doesn't really change anything for us. Now, if this starts out minus, all of the other terms are pluses in that second factor. Look again. My x minus 1s are going to cancel, and I can plug in 1 now. I would get 1 to the fourth plus 1 to the third plus 1 squared plus 1 plus 1. And my answer would be 5. Now we're going to do one more here, and this one is a little bit tougher to do, because I've got a cubic on the top. It's not a difference of cubes. It's not a sum of cubes. It's not a nice cubic. The bottom even involves a little bit of work, but the one thing I know, if I plug in 2, I'm going to get 8 plus 4 minus 2 minus 10. Well, that gives me 0. On the bottom, I get 4 minus 6 plus 2. That also gives me 0. I end up getting 0 over 0. It's an indeterminate form. And again, that just means for us that we are going to have to work a little bit harder to get my answer. Now, remember what I told you about limits. If you have 0 over 0 and x is approaching 2, I can tell you a factor on the top and the bottom right now. What is it? It's x minus 2. The bottom, other factor is easy to figure out. Well, it's going to be x. What should I multiply by negative 2 to get a positive 2 right there? I'd have to multiply by negative 1. There's my factorization on the bottom. Now, what am I going to do on the top? One of the things you can do, and I'm not sure if any of you were ever taught this. If you weren't, here's what we're going to do. We're going to do something that's called synthetic division. Okay? You know there is an x minus 2 on the top. If you set x minus 2 equal to 0, you get x equals 2. That's the number that goes out front right here. The numbers that go inside this little box for synthetic division are the coefficients you see from this original polynomial. 1, 1, -1, -10. Now, if you've never seen synthetic division before, pay close attention to what we're going to be doing here. The first number, you just drop it down. You get 1. Now, what I'm going to do is I'm going to take this 2 times this 1. That gives me 2 in the next column. What I'm going to do is I'm going to add that column to get 3. We are going to do it again. We're going to take this 2 times this 3, and I'm going to get 6 over here. Add that column. I get 5. One more time. I'm going to take this 2 times this 5. That gives me 10. And that last number is 0. And ladies and gentlemen, that last number is the remainder. And I want that remainder to be 0, because that means x minus 2 is actually a factor. Now, how does this work? Well, this is technically x cubed right here, and u divided by x here. So this should come out to be x squared plus 3x plus 5. That, ladies and gentlemen, is my other factor. Look again. I am going to get rid of that common factor on the top and the bottom. I'm going to cancel them out. That gets rid of my 0 over 0. And what I can do now is I can plug in numbers. On the top, I'd get 4 plus 6 plus 5. That's going to give me 15. The bottom's going to be 2 minus 1, which is 1. My answer to that problem is 15. So I've shown you several methods here that you can use to factor and cancel. We've got sum and difference of cubes. We had a difference of squares. We're factoring polynomials. Showed you some synthetic division. Hopefully all of this will help you in your class once you start working on limits and factorizations. If you like this video, please hit the like button. Also, if you like these videos that I'm giving to you, please subscribe to my channel. I'll be providing more videos later on.